First question, in the diagram we have a curve, right? And this is the equation. And the curve itself has a tangent, which is this straight line, at point P, right? So part A, we need to find the coordinates of Q. So Q is the y-intercept of this line. But in order to find y-intercept, we need to have the line equation first, right? So to form line equation, we need to have two things. One is the point, which we already have, but the other one is the gradient, which we don't have. Alright, so let's think about this. Using integration or chapters related to integration, what is the other way to find gradient? Right, so I'll let you all to have 5 seconds to think about this. So the answer is, in the previous chapter, which is differentiation, we have learned that m equals to dy over dx. So m here is the gradient of the tangent of a certain point. It can be calculated through dy over dx, right? So let's find out dy over dx for this case. So we can use the curves equation and then we differentiate, right? So if we differentiate means the power, we need to move to the front, which is 2x, and then the power into minus 1. So there will be x only, and this 4, if we differentiate, it will become 0, right? So this is our equation. And now for the x, we just substitute the x coordinate of this point, which is 1, to find our gradient, which is 2. Right? So now we have the point and the gradient, then we can use the y equals to mx plus c equation, sub the values, and we find the y-intercept. Okay, so our y-intercept is 3, so which means q's coordinate is 0, 3. And the next question is, we need to find the area of shaded region, which is somewhere between the curve and the straight line. So in the previous video, lesson 8, I've mentioned that to find area of shaded region, we need to have 2 steps. Okay, so the first step here is to choose our axis. Either it's the y-axis or the x-axis. So I've also given a tip that if you see smiley face or sad face, usually we should use the x-axis. Okay, so let's use x-axis for this question. And step 2, which is to identify the shapes. So if you see the region that we need to find, it's between these two lines, right? The curve and the tangent. So another technique to help us find area is big shape minus small shape, right? So for the big shape, since we are using x-axis, right? So the part of the curve that we need to focus on is here. And using the x-axis, we find the area under the curve. And this area is actually our big shape because it includes the shaded region. But then the issue is it includes the part that we don't want. So this is where minus the small shape comes in, right? We need to, from this green shape, we need to remove this one. And this one is actually the trapezium, right? This is actually the trapezium. So area under the curve, then we minus out the area of trapezium. And by minusing, we can find the area of shaded region. So for this one, we can use the integration way to help us calculate. This one is just using the area of trapezium formula to help us. So how do we use integration to find area under the curve? So we do have our integral, and since we are using x-axis, outside should be dx. So x outside, inside should be y. And the range that we need to integrate, we have to look at the starting point and ending point for this region. Okay, so the starting point is 0 and the ending point here it is 1, the x coordinate of p. So the things inside the integral later on must be x only, so we can substitute using the equation from the curve, right? X squared plus 4. And to find the area of trapezium, so it's 1 over 2 multiply the length of these two parts, the right side and the left side. So the left side here, because Q we know that the y coordinate is 3, so the length here should be 3, and this one the length is 5 because the y coordinate here is 5. So add them up together, then we need to multiply the width, which is here. Okay, here. So we know already lah, this Z width is actually the 1 because the x coordinate of P is 1. Right, so this one we need to integrate. So x squared here, the power plus 1, and then we need to divide the new power, 2 plus 1, 3. Okay, and then for this 4, we just add an x, and for 0, 1, make sure you put it on the right side. Okay, and then we simplify this one, we'll get minus 4. Then later on for this one, you substitute 1 inside first, write out the working, alright, and then we minus the value that we sub 0. Okay, so this one, I just put 0 because if you substitute 0, everything will become 0, right? So we just put the 0. Then later on, we just simplify and we'll get our answer, which is 1 over 3 unit square. Last question, find the generated volume in terms of pi. So this means for pi, remain as pi, don't change it to 3.142, right? So the region that we need to find the volume is bounded by the curve, right? Bounded by the y-axis and bounded by line y equals to 8, right? And this region we need to rotate fully around the y-axis, right? So the region here should be this part. Okay, so to find volume, we have 2 steps. So the first step is to choose our axis, similar to finding area, but the difference is the question will tell us to use which axis. So here is the y-axis. Step 2 is to identify the shapes similar to finding area, but for this one I would recommend students to take a step back. Instead of finding volume, let's imagine ourselves we are finding area. Okay, so to find area and using this region, okay, here if you're using y-axis, this means this part is actually area under the curve, right? If we go from this way, this is actually area under the curve. So the whole region we can find through using integration, right? So this means if area we use integration, this means when we are finding volume, we should also use integration. Okay, we don't need to like minus the small shapes or adding other shapes inside here. This one pretty straightforward. To find volume, just use the integration formula. And you may be wondering, hey teacher, why did you include this part but did not include this part? Technically this part is also bounded by the 3 lines. Okay, reason is because later on we need to rotate around the y-axis 1 circle, right? So if you imagine this region is rotated, this part technically is also included, right? So we just focus on one part only, okay, instead of left and right, 2 parts. Right, so now let's use the using integration way to find the volume generated. Right, so the first thing first, we need to multiply pi, and we need to integrate in terms of y because we are using the y-axis. So inside must be x, but we need to add a square. Please remember, a lot of students will forget about this. And we need to find the range. So since we are using y, we need to look at the y-axis. So the lowest y value here is actually the y-intercept of this curve, which is 4, right? So if you put x equals to 0, then you will get the y-intercept already, right? And this line is given that y equals to 8, so we need to integrate from 4 to 8, right? And for this thing, we need to change it where everything must be in terms of y, right? So we can use this equation to help us. So we rearrange the equation a bit. So x squared equals to y minus 4, and we substitute this part here. Okay, then later on we need to integrate. So here y will become, so the power is 1, so we do plus 1, and then we need to divide the new power, which is 1 plus 1, 2. So here will become y squared divided by 2, and the 4 we just add a y. And don't forget to put the range here. So the next line is we substitute the 2 values inside. So this is the working where we substitute 8, and this is the working that we substitute 4. then we simplify. So this one is 0, the negative, let's remain here, and this one is negative 8. So to find out the final answer, the answer will be 8 pi units cubed. Again, the pi don't change it to 3.142 because here it says in terms of pi.